the Dogecoin or Dogcoin. So
Yeah,
it seems
Dogecoin.
that is so it's a stock, right?
Well, I think it's like like somebody made it. It's like a meme stock. I don't know, like a meme coin, if you know what that is. It's like it's
Okay.
talked about on Reddit.
Yeah, but it's crazy. Yeah, say over the last week, I think its value increased 4 times, right? 4 5 times. So
If you look at the last 3 months, it's like 1,000-something%.
well, so but say for the past 5 or 6 years, its price is like 1% of a cent. So yes,
Yeah,
you got to be really you got to take a big a very huge risk if you invest on that. But I mean, yes, if you want to go for higher revenue, then you should definitely have to take higher risk. Okay, so let's continue our lecture on the graph board. So last lecture we mainly learned two things. The first one is how to represent a graph by using computer programming, and we introduced two representations. The first one is called adjacency list. So basically, for each node, we create a linked list, which records all of its neighbors. The reason why we use the linked list is because so the nodes could have different number of neighbors. So we don't know. So basically the length or the number of neighbors is a variable. So that's why we use adjacency. The linked list in the adjacency list representation. And then we learned another representation, which is to create a matrix or 2D array. So if we see a one in a cell, it means in the ij cell, it means that there is an edge from the ith vertex to the jth vertex. So this is what does the adjacency matrix representation mean. And then we learned the first algorithm named breadth first search. So if you remember, the way so in breadth first search, we got two input parameters, which are the graph G and a source node. So the idea of breadth first search is this. So suppose, okay, let me use the traveling as an example. So suppose here you'll say this is the United States. This is the US map, and this is your south, which is your home. So then if we follow the way of BS to traverse all the nodes or all the cities in the country, so it is like first you're going to visit the cities that are very close to your hometown. So you're going to visit every city that is just on the neighbor, that is just next to your hometown. And then, so after you finish visiting the closest cities, so now you increase your visit radius or search radius. You go to visit the cities whose distance is, let's say, for example, 100 miles from your hometown. And then next you visit the cities that are within the range of, let's say, 500 miles of your hometown. And you gradually say, so we gradually increase the search radius so as to visit all the cities in the country. So this is the logic or the idea behind breadth first search. So breadth, you can take breadth as the radius. We slowly increase so we start with the smallest radius. So which is 1. So basically we want to visit all the nodes whose distance to the south node is 1, and then we visit all the nodes whose distance to the south node is 2, and etc. So until we finish visiting all the nodes. And this is the idea behind breadth first search. So And then let's talk about, say, again, this is the map. Let's talk about the other way of visiting a place. So again, say, for example, this is your home. Let's say this is Montclair, which is your home. And then you want to visit the cities in the country, in our country. So what? Let's put it here, okay? So and then so you may say, okay, first I want to visit north. I want to go to visit the places to the north of Montclair, of your home. So first, maybe you go to visit Boston, and then you go to visit some other place. Let's say Acadia National Park, located in Maine. And and then you come. Okay, after you reach the border between the between the US and Canada, and then you come back home. Okay, so and next time, say you say, okay, I want to pick another direction. So you maybe say this time you say, I want to visit south. So you visit all the cities to the south of you. So first you go to visit DC, and then you go to visit maybe Atlanta, and then you go to visit another place, let's say Miami. Okay, so so after you visit all the places to the south of you, and let me mark it with a different color. This is our south. After so after you visit all the places to the south of you, and so you come back home again, and next you pick a direction. For example, you want to visit east, and unfortunately to the east of Montclair, I think there are only like the city. It's only the city and maybe Long Island, and then so after you visit Long Island, you come back home, and then next time, say now you say, okay, I want to visit other places to the west of me. So say, for example, you first visit Chicago, and then maybe St. Louis, and then STL, and then you go to visit LA, and then come back after you finish visiting all the places to the on your west, and then you come back home. So this is another way of visiting all the places that are so traversing all the places or all the nodes inside the graph. So so here you can see that each time after we pick one direction, we go to we go to visit all the places in that direction, and then so we come back home. So these are just two different ways of visit, and we call this way depth first search. So here depth means that after you pick one direction, you just go to the very end of that direction and come back home. Okay, so this is just these are just two ways for us to visit the nodes inside a graph. And today we're going to learn this way. We call it, so in short, we call it DFS. Okay, so and here before I introduce the pseudocode of that, so here let me ask you one question. Okay, for each city other than the south, so how many times do we need to visit them?
Is it twice?
Yes, great. So let's take the south as an example. Okay, so we visit DC twice. The first time is that when we just go south. So this is the first time that we visit. We call it the discovery time. We associate it with the discovery time. It means that what is the first time that we visit? We call it D. We use D to denote the discovery time for this node. And then we go all the way to the we continue going south to visit Atlanta and Miami, and then on the way back home, we will go past the DC another time. So this is the time that we're going to see farewell to DC, because after we see DC this time, we arrive back home, we will never visit the south again. So we use F to denote the finish time or farewell time. So here we can say that we visit each node. For each node, we visit them twice. And so we call the first time we say that the timestamp that we first visit them is the discovery time of the node, and then we have a finish time of that node. Great. Okay, so and this is the thing that is relatively important for us to understand depth first search. So far, do you see the difference between breadth first search and depth first search?
Well, for breadth first search, you only have to visit each node once, I guess.
Yeah. Okay. Yes. Okay. Cool. For breadth search, yes. For BFS, we just visit each node once, exactly once. Great. And so, is there any other difference? Okay, I'm just going to use another color, the blue color, the green color, to denote the way that we visit these cities for BFS. If we follow the BFS way to visit all these cities, we are going to do this. Okay, first we visit the places that are closest to the hometown, so like Boston, Chicago, DC, and NYC. So maybe the search radius is like 200 miles or 300 miles. And next we increase the search radius to, let's say, 1,000 miles, and and next we're going to visit these cities, and then at the end we're going to visit the places that are farthest from the home. Okay, but so now you see the difference between BFS and DFS, right?
What's technically the main difference?
The main difference is the order. So let me say, like what I discussed before, the black color represents the order fast to visit the cities in the depth first search way. After you pick one direction, you go to the very end of that direction and then come back home. So this is DFS. For BFS, it's like initially we only visit the places that are very close to the hometown. After we visit we visit the places, let's say, whose distance to our hometown is maybe 1,000 miles, and then we increase the next after we visiting. Well, we get bored with these places. We increase the search radius to maybe 2,000 miles. So in order to cover LA and Miami.
That makes sense. Okay.
Okay. So so this is the biggest difference between breadth first search and depth first search. So and here, this is what I showed with the picture over here. So on the right hand side, we see DFS. The way A is the starting node or the source node. The way for us to visit to start the visit is like we first visit B and C, who's starting from A. We first visit B and C, whose distance to A is just 1, and then we go to visit D, E, F, G, whose distance to A is 2, and then H, I, J, K, whose distance to A is 3. So this is BFS. Whereas for DFS, initially after we pick the let's say we want to go left, so we go to visit B and D and H. So H is the leftmost node. So and then we make our return home and then go to pick another direction to visit. So this is the DFS thing. And here is the pseudocode of depth first search. So it includes 2 functions. This is the main function called DFS, which only takes one parameter called which is the graph G. So here you can see that for each node, we also associate with them each of them a color and a pi. So do you still remember what does colors? So what's the point of using color? We also use colors in BFS. So yeah, why do we use them?
The white was the one that the node hasn't been visited. Gray, I think it gray. I know black was it already got visited.
Right. Cool.
I forgot what gray was.
Cool. wonderful. Okay, so yes, in BFS we also use the colors. The main objective to use colors is to mark, okay, which nodes have been thoroughly visited, so that in the future, if we don't need to visit them again to save time. Okay, so this is the point. And similarly in DFS we also use colors, and we also have 3 colors: white, gray, and black. So the white color means that if a node color is white, then it means that the node has not been visited. It's like a piece of white paper. We have no idea about it. And we give a node a gray color if we finish visiting this node, but not all of its neighbors. So, and we give it a black color if we finish visiting both this node and all of its neighbors. So if we say a node which has a black color, we will not visit it anymore, because yes, we have it has been thoroughly visited. So and here in DFS we keep these colors. We keep using these colors. And similarly, and we associate each node with a pi. So what does pi stand for?
It's the parent of that node.
Yes, cool. The parent of that node. And we say in last lecture, I think we learned that the main purpose to associate each node with a pi is to recover the shortest path. Right. So so if you are at a node and you go to its parent, and from its parent you go to the parent of its parent. If you keep going this way, you will be able to find the shortest path. Cool. So and in depth first search, we still keep these two attributes for each node, and but additionally we have 2 other properties which we call them D and F. So in breadth first search, we also have D, and we use D to denote the shortest distance, the minimum distance from the source node to this node U. But here D has a different meaning. It means the discovery time. So like what I explained over here, for each node we will visit each node twice. So D represents the discovery time. 1 is the first day we discover this node, we visit this node. F means finish or farewell time. So when do we visit the node for the second time and the last time? So so here you can say that we associate each node with 2 times, the discovery time and the finish time. And this is the then let's come to this pseudocode. So initially, for each node in the graph, we associate it with a white color and a new parent, and then we set the time at 0. It means like we start our first day, so it's the 0 state, the beginning of our visit. And then for each vertex of the graph, if its color is white, meaning that it has not been visited before. Here, so if the color is white, it means that this node has not been discovered yet. So we call the DFS visit function to visit it. So when we call the DFS visit function, so first we increase the time, meaning that 1 day passed. We just arrived at this city, and then we associate we set the discovery time for this node. So this means that if you're here, D means the time that we first visited this node, okay? And then we turned we changed the color of this node from white to gray, because yes, now we just visited this node or this city. And then for each V that is adjacent to U, so if its color is also white, and then we assign a U as its parent. This is the same as what we did in BFS. And then we call the DFS visit function to visit its neighbor V. So after we finish visiting all of its neighbors, all of the neighbors of U, we will change the color of U to be black. And this is consistent with what the definition of the black color. After we visit both this node and all of its neighbors, we change its color to black, and then we increase the time, saying that, okay, one day passed, and then we also so this is the second time that this is the time that we're going to say goodbye to this place, and so we associate it with a finish time. Okay, so this is the pseudocode of DFS function, and here you can see that the DFS visit function is what?
It's recursive.
Yes, it's recursive. It keeps calling itself, so it's relatively hard to explain the logic behind a recursive function, and so I'm not going to explain the details of that, and neither do I require you to implement that. Okay, so we rarely use DFS in practice. So BFS is a more favorable choice. And I'm pretty sure that in your job interviews you will not be asked to write the pseudocode for DFS. So that's why I put it. I don't require you to have a very good understanding of it, as long as you know this. Okay, so the output of DFS is like this. So for each node, we got two values. On the left-hand side, it is the D, the discovery time, and on the right-hand side, it is the finish time. So here for the node U, we say its discovery time is 1 and its finish time is 8. It means that we firstly visit this place on day 1, and we secondly and lastly visit this place on day 8. Okay, so and this is the discovery time and the finish time of V. And similarly for the other nodes, we also have these two different times. And and here these two times are totally different from the output of BFS, because in BFS, what is the output of BFS? Let's talk about the output. What is the output of BFS?
Just the shortest path from like.
Yes,
from like
the minimum distance from the source node to any node U, for any U belongs to the graph, correct? Correct?
Yeah.
Okay, we learned the minimum distance between the source node and every node in the graph. But in DFS, for each node, we basically learn two things: the discovery time and finish time. So, and these two times do not convey very straightforward meaning for us, but they will be used in the two algorithms that we're going to learn next week. So that's why, and this is the reason why I say that you will not be asked to implement DFS in your job interview, because there is no point to just ask a person implement a DFS function. You cannot verify. We cannot verify if the results are correct or not. So that's why I put it optional and only introduce it in a very lightweight way. Okay, so the only two things that I want you to know about DFS is the logic. First, it is that we are going to pick one direction and go to reach the very end of that direction. And then the second thing is that the output includes is this: for each node, we learn the discovery time and the finish time, okay, and which will be used in later lectures. So these are the two things that I want you to learn about DFS. Okay, so any question for me?
Quick question: is BFS something that we would have to implement in a job interview? Like
Yes, yes. It's almost going to show in every interview.
Oh, okay, I see.
Yeah. Okay. Yes, it's really popular. Okay, so maybe next week. Yes, next week I'm going to show you a coding question that I got. Not one, actually 3 coding questions that I got from my job interviews. Okay, so and you'll be able to have a good feeling about so what is a coding interview look? What does a coding interview look like? Okay, so any other question for me regarding depth first search? Yeah, LeetCode is a great resource. Yes, but so if you don't know what is LeetCode, just check the chat area. I think Louis. Did I spell your name correct?
Yeah, that's correct. Yeah, Louis.
Okay, pronounce your name correct, Louis. I think Louis. So post a very good resource called LeetCode. Just need to Google it. And this website is basically like you are going to see a lot of real world coding questions, and but it's maybe it's too hard for you guys. So when I was I'm not sure if I mentioned this before. When I was like preparing my job interviews, I also use that for software engineering jobs. I also use that. But at the time, because I was in the job, the last time I was on the job market, it was like 2016. And during that time, there are only like 400 questions on LeetCode, coding questions on LeetCode. And now I think it should be way more than 1,000, maybe even 2,000. I don't know. I haven't checked it for a long time. So it's too many. And each question, I would say, probably take you anywhere from an hour to 4 hours to understand. Okay, 1,700. So if on average each question takes you 3 hours, and times 1,700 questions, so that is 5,100 hours. And say each day you study 8 hours. Let's say on every day you just go over LeetCode, spend 8 hours on LeetCode. Do you know how long will it take? Roughly 630 days. That's too much. The workload is too much, and some of them are really difficult. So after we finish this class, after we finish the data structure class, you can slowly start practicing your coding skills by doing some LeetCode questions, but you don't have to do all of them. Okay, so I got one question from the chatter saying that LeetCode has rankings from easy to hard. I was able to practice even though I hadn't coded in a while. I use it to refresh my memory of Python and Java. Yes, the good thing about LeetCode is that they categorize the questions from based on difficulty levels from easy to medium to hard. But I don't think it's the best. I mean, I don't think the categorization is very all of them are correct, because I remember that even for some easy questions, it took me a long time to understand. So, but yes, it doesn't hurt. So I would say if you want to start it, just start from the easy ones. Okay, so what is the best way to prepare? You mean job interviews?
Yeah, like instead of LeetCode, because like you said, it's gonna be like very difficult.
So I would say before you go to LeetCode, so there is one book called Crack Coding Interview for Fun. I'm going interviews for fun. Okay, read that book. That book is like 300 or 400 pages, and I really enjoy reading it. So after that, you have a much better computer science logic. So my way to prepare job interviews is to first go through our book to refresh the data structures and algorithms, and go through the Crack Coding Interview for Fun book, Crack Coding Interview for Fun book, and then practice programming on LeetCode. So that's my steps, but it takes a long time to get prepared. I mean, you should spend at least 3 months. Spare at least 3 months. Okay, so any other question for me? Yes, that's a book.
Quick question on that book. Is that specific to a certain language or just in like an overall?
It's more like overall, but so in the code, I think they use either Java or C++. I don't remember it very clearly, but they have a language. They definitely need to show you the code, but I think the code is written in one language. But the main object of this book is to train you the logic of solving real world problems by using some data structures like linked list. You have so it introduces you to the very intricate ways to slightly modify some data structures or algorithms to make the work for a specific question.
Okay, thank you.
Any other question for me? Who the book is by? The thing. Let me check it. I don't remember. So it's very sad that I also have a hard. I also had a hard copy of that book, and code interview for fun. So it's a white. I remember the color of this book is white. So let me say. Say. So, but I had a hard copy of that book, but I put it in my office, and I left it in my office. But when the department moves from the old building to the new building, it was lost. So I don't. Okay, I've just found the PDF link of that book. So now they changed the color from white to green. I think I bought the 4th edition or the 2nd edition 5-6 years ago, and at that time it was the cover was white, but now I think they changed it to green color. Okay, so any other question for me?
Actually, I do have a quick question. When
Okay.
you were on the market for software engineering, what did you focus on, front end or back end or full stack?
Back end, full
Back
stack, full stack actually.
Okay,
And
so
but I don't like front end thing, but I don't mind if it's a full stack, but I definitely don't want to be a person who is just on the front end.
okay.
No, so the front end thing, the problem of front end programming is that the job market is going to shrink because some of them are going to be replaced by programs.
Oh, okay. You mean like applications or like?
Yes.
Okay.
There are some now. The people slowly develop some softwares to help you format your code, to smartly to intelligently fill in the code that may be in your mind. So the front end thing is they don't rely on much of your logic. It's more like you memorize some grammar for a certain language, for example, HTML, JavaScript. So, and these things are they follow strictly rules, and which means that they're programmable. So and slowly some of these jobs are going to be replaced by programs, like the cashier at the supermarket.
Oh, but yeah, automated. Yeah, the automated
Yes.
systems are definitely.
Yes.
Mhm.
But the backend thing is more like your logic, something it relies more on your computer science mind. So it's and people have already proved the research have already proved that programming is generally NP hard. Do you still remember the term NP hard? The complexity is exponential, which means that so this kind of job cannot be replaced by programs, or even though people design a program, so that program is going to take years, thousands of years to finish. Yeah. So the backend jobs are safe. No robotics or no artificial intelligence thing can replace that.
Okay, all right. So then I have another question for you now, since we're focusing on the back end. For a portfolio, what ideas would you recommend to create a portfolio? As a backend, because that's actually what I want to pursue as well. So
okay, so what you want me is portfolio management, right? So here, let me show you some research that I'm currently doing. So it's hard. I mean, I cannot give you a very straightforward answer, because the situation depends. It depends on how is your tolerance against the risk. So here, let me show you something. Can you say it?
Yes.
Okay, so here I'm just using artificial intelligence, or another term is say the reinforcement learning. So if you don't know reinforcement learning, do you play any game like Dota 2?
Do I? No, I haven't played any.
Or say play any video games. Basically, the AI in those video games, the bot in those video games are trained by reinforcement learning. So which is like they try to predict. Basically, the bot is going to predict what is your action, so as they come up with a better action to beat you. Okay.
Yeah. Okay.
So it comes but they need to collect a lot of game replays in order to do the analysis. So here, what I'm doing is that I'm just collecting some stocks, and here you can say this is the AA. I don't remember what does A stand for. Here, maybe American Airline, and this is XP, American Express. It's historical price in the last 20 years or so. And I'm training an artificial intelligence bot to do the trading for me. And this is the performance, that how much money. So the initially I put $100,000 in. On the first day of 2011. Here you don't see the year clearly, but the first day is it started trading on. I just do some simulation, and here you can see that. It vibrates. It basically it tries to predict the market and make the best exchange or trade.
Okay, so
so over the 10 years, so this is how much money do I earn by using $100,000 over the term of a little bit over 10 years. And here you can see that I basically earned over, like, eventually I can get I'm expected to get over 100% revenue, but I cannot say that. I cannot say okay, if to answer your question, I cannot say what is the best portfolio, because it changes, and different people have, as I said, different people have different risk tolerance. So yes, you have to do a little bit of research myself.
Yeah. Oh yeah, I'm definitely good research before I start making one. Thank you though.
Okay, no problem. And okay, so the other question that I got is what branch of computer science is good for master degree? Only two, either cybersecurity or machine learning. Basically, data science is also machine learning. So either one of them, if you are considering master degree. But if you are considering bachelor, it's more like I mean, just go for computer science or information technology, but for master or higher level, just those two. Did one of the Allen's companies create a bot strong enough to beat pro players? Yes. There is a company named OpenAI. I think 3 years ago, they developed a bot that beats the best player in the world. Okay, so okay, and okay, so I think I got time to take one more question. Ask me if you have. Because today our lecture is really lightweighted, so cybersecurity jobs involve a lot of coding? Not actually, no. So compared with data science, it's a little bit less. But the thing of cybersecurity is that you have to be very good at cryptography, or in other words, you have to be a math guy. Similar for machine learning, you have to be a math guy. But say in terms of the programming, cybersecurity is less, but it has a higher requirement for your theory, and also you need. Okay, so this is the difference. Do you think that computer science will be overcrowded? No. In 10 or 20 years, no, definitely no. So we're still going to see a lot of job shortages. So the shortage of qualified computer scientists. So the thing is that, okay, even though now a lot of students come to learn computer science, do you expect all of them to be programmers, to be qualified programmers? No. So my experience, I'm going to tell you my experience. Okay, when I did my PhD at say Stevens, so there are 5 PhD students who entered the PhD program at the same time with me. Do you know how many of them received the PhD degree? 2, yes, 2, only 2. And I would say 5 of us are really great, because yes, if you want, so these guys are really great, but only 2 earn it. And the master degree, say the graduation rate at Stevens is around 70%. I mean, computer science, okay? And even though within those 70% who successfully graduate, less than half of them are still doing programming. Okay, so there is going to be a big job, a big market for computer science guys. So if you want to hold a safe job and get a lot of job security and get good salary, yes, you should spend your time on computer science. It's really worthwhile. Okay, so okay, so here I think I'm no problem. So today I think I don't think I have time to go over questions. No problem. So I'm more than happy to answer these questions and clarify something for you. When I was a student, I was also very curious about the outside world, and sometimes I feel lost. I don't know what is going on outside. So yeah, so it's my pleasure. And here I'm going to briefly talk about your homework, homework 8. So which one am I going to share? Okay, so can you say it?
Yeah.
Yeah, we can see it.
Sorry. Okay, sorry. This is a typo. This should be homework 8. So in homework 8, you are asked to implement the BFS function. So you should return an array, an integer array, which records the minimum distance between every node to the source. And here I give you 4 hints. The first one is that I have already defined the colors for you. They're just macros, static, so static constants, variables. So just use them. And then but in the pseudocode we have the operation like this: u.color equal to white. But when you are doing the programming now, you can't do this because u is basically an integer. So you cannot associate a color with an integer. So instead, you can create an array to record the colors of the nodes, and another array to represent the distance. And so when you are doing the homework, you can ignore the parent, so that you don't have to deal with the parent. And also, because if you remember in the BFS function, we need to use Q, and there are some enqueue and dequeue operations. So you can either use the queue that was implemented by you, or you can use the queue that is provided by Java. Basically, in Java, you can use linked list as a queue, and so the enqueue and dequeue functions are just add and remove in Java linked list. So here I provide you 3 links. The first link is the API to the linked list, which is like the menu to the linked list. So and then I provide you 2 tutorials. So this is like the examples how the other people use linked list. So this is like when you learn to repair a new car. So for today, you just got some people just ask you to repair his BMW, which you have never repaired before. So what you need to do is that first you need to check the menu, which is in the computer science world we call it API. This is the link to the API, and after that you just go to YouTube to watch a couple of videos from the other people to see how do they fix the cars. So these are just the tutorial. These are just like the YouTube tutorials of fixing cars. But here we're just from this you can learn how to use this data structure called linked list, and that is provided by Java. So in the future, you are going after you go to your job, you are going to there are a lot of opportunities for you to learn to use a new data structure that is provided by some library. And this is how you are going to learn. First, check the manual. Secondly, go through some tutorials. So I hope this can provide you as a way to learn how to learn a new data structure, how to learn to use a new data structure. Okay, so this is the BFS. And then if you really want to challenge yourself and earn some 100 extra credits, you can go to implement the DFS and DFS visit function. But this is going to take a long time. Let's say prepare at least 3 or 4 hours for that. Okay, so yes, this is what I want to discuss for today. And any question before you go?
Nope. Thank you very much, Professor.
No problem.
Professor, what classes are you teaching next semester?
Next semester, I'm still teaching to 12, and also I'm teaching a graduate level, big data analytics. So yes, my main course to teach is just this one, data structures, and I love this course, and I think it's important. So that's why I always ask the department to assign this course to me. Okay, so any other question for me? No problem. Yes, then yes, have a good weekend, everyone.
Have a good one, Professor.
Thank you, Professor. Have a good weekend.
You too.
Have a good weekend.
Thank you.
Hey, Professor, I actually have a question. I'm sorry.
Sure.
So for to become a backend engineer, from my understanding is that you need to be proficient in programming.
Yes.
You need to understand or know a certain frame, because I want to get into web development. So I've read that you should know a framework to help you. I guess so you don't reinvent the wheel. Like you can use a lot of the code in the framework to help set up your backend. So I noticed that databases too, which is something you should be familiar with, depending on the language that you choose to pursue. So you need to know the databases. And what else would you say is like a necessary, like algorithms? Yes, and certainly data structures. You should know. What is something else that you would say that something you should focus on? You know, making sure understanding.
Okay, so for you to get a starting job, to get the first job, two things. This course plus the database course. So with these two courses, you can definitely find a job, a landing job as a backend software engineer. And after that, it's totally up to you. No course. You just learn from your jobs and take your curiosity and do not just work, also learn. Okay. So if you work, you're just producing value for the company, but you are not producing value for yourself. So only by learning some new stuff, you make yourself worth more.
So would you say for like an entry level job, would it be like, do you think that it's mandatory that you know a framework or
no? Like because like in terms of framework, there's something like Struts or Spring, but I mean they're not very difficult for you to learn after you find a job. So yes, and different, and I don't think people use those frameworks very often nowadays. At least because maybe my area is I'm doing more research, so I don't do a lot of engineering work, so I don't use them very often in my daily work.
Okay, all right. I think that's it for my questions. Thank you so much. All right.
No problem.
All right. Have a good weekend.